we've made really good progress. We now have 3 classes. The one that we started with was the import data, where we get data from a text file. We've done the user file class, which is going to allow us to handle the data that we find in the text file that contains the logins and passwords, the usernames and passwords. And now we've got an access to the data file using the import data, populating users, checking whether the username and passwords are correct. And so everything's looking okay so far. It all builds successfully. So the next thing we need to do is we need to start to work on the loan. Remembering our application for the motoring application is going to deal with 2 things. It's going to be about buying a car, and it's going to be traditional loan arrangements, nothing fancy like part ownership or end payment 10 years and stuff like that. It's just going to be traditional hire purchase where you have a cost price, you pay a deposit perhaps, and then you agree the term over which you will repay the car and the interest rate at which the loan will be given to you. So that's exactly what we're going to work with. It's very, very straightforward and very similar to the mortgage in terms of what you get as a compound interest, and you're repaying the whole of the stuff that they've lent you in order to buy the car and buy the house. So that's what's happening. Before we start on dealing with the class itself, I want to take you to some of the support that's offered by Microsoft in Visual C#. This is the site. It's doc.microsoft.com, and you navigate into C# guide, and I'm going to language reference because what I want to do is talk about numbers, because there are lots of different types of numbers that are used, as we've discussed before, in C#, and the variation really is in size. So I wanted to talk about floating point numbers first, because this can perhaps be the most confusing of them all. What is a floating point? A floating point is that you are going to use decimals, not whole numbers. And they can be plus or minus, always in the floating types that we use. And you've got various degrees of what are called precision. And at the lowest level of precision is the float. Then we get a double, and then we get a decimal. And we don't particularly need a lot of precision. And in fact, these are going to become maybe obvious in a future application that we do. But at the moment, we just need a float. Now remember the data that we have to deal with in our class. We're talking about an interest rate, and that would be a floating type. So you might get an interest rate of 3.75 or something like that, 3.75% per annum compound. And then for our prices, I think in what we're doing, we won't use decimal points. We'll just consider that the car price is going to be in a number of pounds, not and 99 pence. And that the deposit pounds, again, not parts of pounds unless you're grabbing pennies out of your pockets. And the term in years of the loan will be in whole numbers. We won't say that it's going to be 2.5 years. Another way to look at it would have been in doing it in months, but I think we should just do it in years because that's what we're going to do with the other application that we have to build. So in terms of integral, which are the whole number types, integral types, here are the various ones that we have. And if you look at each one of these are getting to so that they can hold progressively bigger numbers, okay? And you've got the S and then the byte. And look at the car, which is very not really relevant for us. But int, now look at the range of values for int, which is there, as opposed to use a short. Now short, if you use the unsigned short, you get the whole range available in positive numbers. But it could very well be that a car and a house are more expensive than that. So you wouldn't use that for that. So I'm proposing that for the car and the deposit that you're going to pay, you're going to just use the int, because that's going to take us up to 2,147,000,000, etc. I doubt you're going to get a car as much as that. But you could get a car for 65,535 and a lot more. So for our term in years, I think we were safe in using a much smaller number, which is 255, and that's a byte. Now we don't need the negatives. They take up the same space because this uses minus to positive. And this one just uses the positive. So the byte is probably the one we should elect to use for the term in years. So that's where you can get lots of support and look things up about. If you're not sure about a value and whether it's the right size to use, go to the Microsoft support site and do things from there. So let's create our class, once again in the project, not the solution. Right click and add, and it's going to be a class, and we're obviously going to call this loan. So that will create our class, and we'll of course make it public. So I've pasted in the usual commentary at the top here. So what we need to do is we need to create full properties for all of the components that we're going to do. So I think the first one is going to be, prop full. It's going to be an int, funnily enough, and we're going to call this car price. That'll be there for car price. And that's going to be allow us to work with encapsulated data on here, and we won't actually be doing any encapsulation in this class that's effectively going to protect anything at all. But we want to get into this habit of doing things appropriately so that we can use them in the correct way. Now, what I'm going to do, obviously, is I'm going to start to put comments in. And I have this little kind of form that I use, dash price. And that lets us just follow through on the styling. So let's do it again. So this is the deposit. And that's once again going to be an int. So that's good. Now what we're going to do is the term of the loan, and that's normally a kind of a term in years. Now you will see many where it's going to be months, but I'm trying to simplify this to match the other problem that we're coming up with later on when we do something else, as you know. So this is going to be a much more appropriate time base to work with. So I'm going to do a prop full. And this time we're going to say it's a byte, because you're not going to be likely to get anything that's, you're not going to lend you something that's going to be greater than 255 years in length. So I'm going to say loan term years. So it'll be loan term years. And then finally we're going to do the interest rate. And you remember we said that's going to be a rate of interest, typically expressed as 3.75, never as much as 3.75 before, did we? So we would need to use a larger range of precision. So once again, prop full, and it's going to be a float, and it's going to be loan rate. And that's our class complete, because that's all we need to have in this one. It's just a data holding class. We won't do anything about methods in this. I was tempted to put a method in here, or get loan details, which would concatenate all of these things into a single string value. I'll think about that a bit more before I actually make you go through the trouble of doing that, because it might be a good thing to teach you, but we'll just wait and see what happens with that. So that's our loan class complete.